When installing Type TC cable from a cable tray through a Class 1 Division 1 area to a junction box located in a Class 1 Division 2 area, there are several options available to maintain safety and compliance with hazardous location standards. Armored cable may not always be the most practical or cost-effective solution, especially when running a conduit. Sealing conduits with multi-conductor cables can be challenging if the jacket needs to be broken inside a small seal fitting. Firstly, consider using an explosion-proof conduit seal fitting. This type of seal fitting is specifically designed for use in hazardous locations and is certified for Class 1 Division 1 and Division 2 areas. The fitting typically has a threaded connection on one end that attaches to the conduit and a flange connection on the other end, providing a seal for the cable. This method allows for the cable jacket to be stripped inside the seal fitting, ensuring proper sealing. Secondly, you can utilize rigid conduit with integral sealing fittings. Integral sealing fittings are built into the ends of the rigid conduit, providing a seal for the cable without requiring additional fittings. This approach eliminates the need to strip the cable jacket outside of the conduit, reducing the risk of potential ignition sources. Thirdly, explore the option of using an explosion-proof junction box with conduit seals. This involves installing an explosion-proof junction box in the Class 1 Division 1 area and running the conduit through it. Separate conduit seal fittings can then be used to seal the conduit entrances into the junction box. This method provides a sealed transition point between the two hazardous areas. Fourthly, a zone sealing system can be implemented. A zone sealing system involves using a special type of sealant to create a seal around the conduit entrances where it transitions between hazardous areas. The sealant is applied to the conduit threads and the seal fitting to provide a gas-tight barrier. In addition to these options, there are several additional considerations to keep in mind. All conduit and seal fittings used in hazardous locations must be certified for the specific hazard rating and application. Ensure you select components that are appropriately rated for Class 1 Division 1 and Class 1 Division 2 environments. Determination of the Type TC cable at the junction box in the Class 1 Division 2 area must meet the requirements for a Class 1 Division 2 installation. This includes using appropriate terminal blocks and ensuring proper spacing and clearances. The cable must be properly grounded to prevent static buildup and potential ignition sources. Follow the National Electrical Code, also known as NEC, requirements for grounding in hazardous locations. Here's a more detailed look at each option. Focusing on the explosion-proof conduit seal fitting, these fittings are designed to prevent the passage of flames, gases, or vapors from one portion of the electrical system to another. They are typically filled with a sealing compound after the conductors are installed. The sealing compound hardens to form a solid, explosion-proof barrier. When selecting an explosion-proof conduit seal fitting, ensure it is listed for use with the specific type of conduit and cable being used. Also, verify that the fitting is approved for use in Class 1 Division 1 and Class 1 Division 2 areas. The installation process involves several steps. Firstly, install the conduit and cable as per the manufacturer's instructions. Secondly, prepare the cable by stripping the outer jacket to expose the conductors. Thirdly, insert the cable through the seal fitting and into the conduit. Fourthly, pack the sealing compound into the fitting, ensuring it completely fills the space around the conductors. Fifthly, allow the sealing compound to cure according to the manufacturer's instructions. Moving on to rigid conduits with integral sealing fittings, this type of conduit simplifies the installation process by eliminating the need for separate seal fittings. The integral sealing fittings are typically located at the ends of the conduit and are designed to create a gas-tight seal when properly installed. When using rigid conduit with integral sealing fittings, ensure that the conduit is properly supported and grounded. Also, verify that the integral sealing fittings are approved for use in Class 1 Division 1 and Class 1 Division 2 areas. The installation process is similar to that of standard rigid conduit. Firstly, install the conduit as per the manufacturer's instructions. Secondly, connect the conduit to the junction box or other equipment. Thirdly, tighten the integral sealing fittings to create a gas-tight seal. Then, consider the explosion-proof junction box with conduit seals. These junction boxes are designed to contain any explosions that may occur within the box, preventing them from propagating to the surrounding environment. When using an explosion-proof junction box with conduit seals, ensure that the box is properly grounded and that all conduit entrances are sealed with approved seal fittings. Also, verify that the junction box is approved for use in Class 1 Division 1 areas, if that is the specific area you are working on. The installation process involves firstly installing the junction box in the desired location. Secondly, run the conduit to the junction box. Thirdly, install seal fittings at all conduit entrances. Fourthly, connect the conductors inside the junction box. Finally, seal the seal fittings with the appropriate sealing compound. Lastly is the zone sealing system, which provides a flexible and cost-effective solution for sealing conduit entrances in hazardous locations. Zone sealing systems typically consist of a special sealant that is applied to the conduit threads and the seal fitting. When the sealant cures, it forms a gas-tight barrier that prevents the passage of flames, gases, or vapors. When using a zone sealing system, ensure that the sealant is compatible with the conduit and cable materials. Also, verify that the sealant is approved for use in Class 1 Division 1 and Class 1 Division 2 areas. The installation process involves, firstly, cleaning the conduit threads and the seal fitting. Secondly, apply the sealant to the threads. Thirdly, tighten the seal fitting onto the conduit. Fourthly, allow the sealant to cure according to the manufacturer's instructions. In all of these options, grounding is of utmost importance in hazardous locations to prevent the buildup of static electricity, which can be a source of ignition. Grounding ensures that any static charge is safely dissipated to ground, reducing the risk of sparks. The NEC provides detailed requirements for grounding in hazardous locations. These requirements vary depending on the specific hazard rating and application. Consult the NEC for specific guidance on grounding requirements in your application. In general, grounding should be accomplished by connecting all metallic components of the electrical system to a common grounding electrode system. This includes conduit, junction boxes, equipment enclosures, and cable shields. Grounding conductors should be sized appropriately for the fault current that they may be required to carry. The grounding electrode system should be properly installed and maintained to ensure its effectiveness. Additionally, ensure that all electrical equipment used in hazardous locations is properly rated and certified for the specific environment in which it will be used. This includes motors, lighting fixtures, control panels, and other electrical devices. Equipment should be selected based on the specific hazard rating, temperature rating, and other relevant factors. Regular inspections and maintenance should be performed on all electrical equipment in hazardous locations to ensure that it is in good working condition and that all safety features are functioning properly. Any damaged or defective equipment should be repaired or replaced immediately. Furthermore, proper training and education are essential for personnel working in hazardous locations. Workers should be trained on the hazards associated with these environments and the proper procedures for working safely. Training should cover topics such as hazard recognition, safe work practices, personal protective equipment, and emergency response. In addition to the specific options discussed above, there are other general considerations to keep in mind when installing electrical systems in hazardous locations. Firstly, minimize the number of potential ignition sources. This can be achieved by using explosion-proof equipment, sealing conduit entrances, and avoiding the use of open flames or sparks. Secondly, control the accumulation of flammable materials. This can be achieved by providing adequate ventilation using dust collection systems and regularly cleaning up spills and leaks. Thirdly, implement a robust safety management system. This system should include written procedures, regular inspections, and employee training. The safety management system should be designed to identify and mitigate potential hazards before they can cause an incident. By following these guidelines, you can ensure the safe and reliable operation of electrical systems in hazardous locations. The NEC provides comprehensive guidance on the design, installation, and maintenance of electrical systems in these environments. Always consult the NEC and other relevant standards for specific requirements in your application. When dealing with Class 1 Division 1 and Class 1 Division 2 areas, it's crucial to understand the differences and specific requirements for each. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are those where the hazardous material is present under normal operating conditions, frequently present because of repair or maintenance operations, or where a failure of equipment might release hazardous material and cause simultaneous electrical hazard. Division 2 locations are those where the hazardous material is handled, processed, or used, but is normally confined within closed containers or systems from which it can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment, or where the hazardous material is normally prevented by positive mechanical ventilation, and might become hazardous through failure or abnormal operation of the ventilating equipment, or that is adjacent to a Class 1 Division 1 location, and to which hazardous concentrations of gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. Therefore, equipment and wiring methods suitable for Class 1 Division 1 are generally more stringent than those for Class 1 Division 2. For example, in Class 1 Division 1 areas, explosion-proof enclosures are typically required to contain any explosion that may occur within the enclosure, preventing it from propagating to the surrounding atmosphere. In Class 1 Division 2 areas, explosion-proof enclosures may not be required, but other methods of protection, such as intrinsically safe circuits or purged and pressurized enclosures, may be permitted. Also, consider the specific type of flammable gas or vapor that is present in the area. Different gases and vapors have different ignition temperatures and explosion characteristics. Electrical equipment must be selected and installed to be compatible with the specific flammable material present. The NEC provides tables and guidance on selecting equipment for different types of flammable materials. Furthermore, document all aspects of the installation, including equipment specifications, wiring diagrams, and inspection records. This documentation will be helpful for future maintenance and troubleshooting. It is also important to keep up to date with the latest codes and standards for hazardous locations. The NEC is revised every 3 years, and new technologies and best practices are constantly emerging. By staying informed, you can ensure that your electrical systems are safe, reliable, and compliant with all applicable regulations. When selecting Type TC cable for use in hazardous locations, ensure that it is specifically listed and marked for such use. Type TC cable is a multi-conductor cable designed for use in cable trays, raceways, and direct burial applications. However, not all Type TC cable is suitable for use in hazardous locations. Look for Type TC cable that is marked with the suffix HL or hazardous location. This marking indicates that the cable has been tested and certified for use in Class 1 Division 2 areas. Type TCHL cable typically has a rugged construction and is resistant to chemicals, abrasion, and moisture. It is also designed to prevent the propagation of flames in the event of a fire. When installing Type TCHL cable and conduit, ensure that the conduit is properly sized and supported. Also, use appropriate fittings and connectors that are approved for use with Type TCHL cable. Avoid pulling the cable too tightly, as this can damage the insulation and conductors. Another important consideration is the temperature rating of the cable. Electrical equipment used in hazardous locations must be rated for the maximum ambient temperature that may be encountered in the area. Type TC cable is typically available with temperature ratings of 75 degrees Celsius or 90 degrees Celsius. Select a cable with a temperature rating that is appropriate for the specific application. In summary, running Type TC cable from a cable tray through a Class 1 Division 1 area to a junction box in a Class 1 Division 2 area requires careful planning and attention to detail. By following the guidelines outlined above, you can ensure that the installation is safe, reliable, and compliant with all applicable regulations. Remember to consult the NEC and other relevant standards for specific requirements in your application. The options presented, including explosion-proof conduit seal fittings, rigid conduit with integral sealing fittings, explosion-proof junction boxes with conduit seals, and zone sealing systems. Each offer unique advantages and may be suitable for different applications. The selection of the most appropriate option will depend on factors such as cost, ease of installation, and the specific requirements of the hazardous location. Regardless of the option chosen, it is essential to ensure that all equipment is properly rated and certified for use in hazardous locations and that the installation is performed by qualified personnel. Regular inspections and maintenance should be performed to ensure that the electrical system continues to operate safely and reliably. And as always, safety should be the top priority when working in hazardous locations.